Did you know India does over 600 million UPI transactions a day? That translate to 2.4 billion transactions on the backend systems? Did you know when European Space Agency maps the entire space for the mankind, they are dealing with data as vast as the space itself? Did you know DreamWorks renders frames at 400 gigabit per second to produce your favorite movies? What's common in all these? It's data at massive scale and extreme performance. To NetApp powering all these extreme scale workloads. We tap into every signal produced by our systems to offer predictive performance, reliability, and availability to our customers. We do this by using time series data to generate insights. GenAI and LLMs can work best with text, video, and images. But how about time series data? Here we have someone who has cracked the code of time series. Ladies and gentlemen, my pleasure welcoming Synthefy onto the stage to tell their story today. Welcome Raghav onto the stage.
Thank you so much, Saji. Can I get a big round of applause for Saji's intro? My God, what an intro. Uh, yeah, so a little bit of myself, but I'll come back to this. Let me just start off right away. Can I get some? There we go. Okay. So we have been talking a lot about LLMs, and they're incredibly powerful tools, right? But enterprises, what kind of data do they work with? Enterprises mostly generate time series and numerical data. Let me show you a few examples of what I mean. So let's say you're an Airtel executive, right? And on the eve of Diwali, some rockets have hit your cell towers, and some of them have gone down. On the morning of Diwali, a whole bunch of angry customers call you, and they ask you, why can't I talk to my family? And you do not want a repeat of this next year, right? Purely hypothetical. Here in orange is the time series, and in purple are contextual clues. So it helps a lot to know which city you're talking about, Bengaluru in this case. It helps a lot to know 1% of cell towers are down, because this massively improves the quality of forecast, as you might expect. Why would you want to ask a question like forecast network congestion in Bengaluru on Diwali if 1% of cell towers are down during peak hours? You might want to do stress testing or predictive maintenance, which is fixing critical components of the system even before they have the opportunity to go down. In fact, this is the exact problem that we solved for Deutsche Telekom and T-Mobile in the AI for Telecom challenge, and we placed first out of 360 companies to do this. Another question. Let's say you're NetApp and you want to forecast storage utilization over the next 90 days, but you want to keep in mind that there's been a spike in AI usage for your customer, and they also have hybrid cloud workloads deployed across a wide range of clusters. This will help you to do capacity planning and customer demand forecasting. More on this later. So let's say you're a retailer and you ask, what happens to my revenue and cost if I increase ad spending by 10%, considering market sentiment from social media like X and Reddit? So here there are two time series in orange, revenue and cost, and the contextual clues in purple are also multifold. And you would want to use this for demand forecasting or scenario simulation. In fact, we're engaged in pilots with large retailers to solve this problem for them. Why do I say that current GenAI models cannot process time series? We're so accustomed to them solving every problem, right? But the thing is, like Saji said, they trained on language, image, and video data. So this could be blogs, this could be code, or this could be TikTok reels. So when you ask them to write blogs or write code or generate TikTok reels, they're so good at it. But they've never seen time series data. So when you provide them time series data, like throughput or cache misses, then they fall apart. And they will say things like your CPU will run at 634% of capacity. This is something we've actually seen, by the way. And you never want to see something like this in your production systems, right? So there's another important question. A lot of us are used with traditional business intelligence tools, things like Arima or Profit. Why do they not work? Well, they cannot handle multimodal data. Let's say you have system load, but in addition, you have text information about the workload. that you're deploying. So classical time series tools like Glue on TS or Prophet or Arima, they can only handle one time series at a time. So what happens if you give more? They just throw it all out. And since they cannot process this additional information, they fail. And we've seen this over and over with our clients as well. Enterprises, I've given you 3 examples of how enterprises generate multimodal data which involve time series and text. So since enterprises generate multimodal data, they need multimodal AI, which handles this data effectively and forecasts it well. And that's exactly what we at Synthefy has built. Starting from the left, Synthefy will take your time series, which could be pricing, it could be ad spend, it could be competitor pricing, and so on. It'll take your tabular data, which could be catalogs. It'll take your text description of the product you're selling. And it'll synthesize all of this information together and do a joint forecast, which is insanely powerful. So in the center, you see the APIs that power our applications, which are forecasting and scenario simulation, which I've touched upon previously. How does this matter to you? Well, we do things like capacity prediction, predictive maintenance, and revenue forecasting. And what is the secret sauce that powers our APIs? We have built an in-house foundational model. So think ChatGPT, right? Which is trained on a wide variety of data. We've done the same thing for time series, and we're really, really good at it. So no matter what kind of data you throw at us, we will take it, and we will predict it with confidence. A little bit about myself now. I'm Raghav, and I work at Synthefy as a research engineer. I've had a lot of experience working in compute and ML. In fact, while I was at IIT Madras, I had the privilege to take a course by Professor Nasre. If you think he's a great orator, you should see the way he teaches. It's incredible. I have previously also worked with Microsoft, where I saw this huge disconnect. The customers would come with this data, but we would have built tools that don't really work well. There were questions previously about the insane investment into GenAI, which is not really panning out for a lot of customers. And that's the problem Synthefy solved on day 0. And we shipped on day 1. So we have the prestige and the expertise to back up our claims. We've come from some of the greatest academic and corporate environments that you might know of. We have ongoing contracts with Fortune 500 companies, including Samsung, Cisco. We're talking to hedge funds. We also have an ongoing contract with the US Army and several large retailers. I've told you about the Deutsche Telekom and T-Mobile AI challenge. We've also been recognized by IDC as one of the most innovative synthetic time series companies. And the crown jewel, we've built and published the Migas 1.0 model, which is one of the best models on the leading time series benchmark in the world, Giftival. And we beat Google and Amazon to get there. Despite their much larger investments, we were able to beat them just on the quality of our research and the quality of our team. Now let me not just say we're the best, let me prove it to you. Here's a case study on the work we did for a large telecom. So this large telecom had extensive metrics, tracing, and logs, and they were using traditional time series tools to predict failures, but they were unable to do it for 3 years. We came in with our foundational model, and we were able to predict failures with a precision of 90% and completely prevent 40 million hours of downtime. And we're able to do this in a pilot, and we're taking this to the production stage right now. So this is the power of our model. We've also worked with a large US retailer to improve the revenue by 12% for a particular product in their portfolio. And this is a retailer with an $800 million annual revenue. So they came to us with their historical sales data, along with competitor pricing and product category. We went out and fetched Wikipedia trends and Google trends, which will act as market sentiment about the company. And using the exact same model that previously worked with network logs, we were able to predict the pricing, right? So what you see on this graph on the x-axis is the sales price, which we varied between different values, lower and higher than the actual price. And then on the y-axis, you have the expected revenue for a particular store for a particular hour. And that's something our fine-grained APIs allow you to do. Very careful and useful insights. And you can see that the price that was picked by the retailer with their business intelligence did not match our price, and our price promised a 12% increase in expected revenue, which was borne out. A third and final use case with the work that we did for NetApp. So Saji and his team came to us with customer telemetry data, which included throughput, cache misses, and CPU utilization. And they wanted to forecast customer usage of 2 of their compute clusters. The problem that Saji's team was facing was with their forecasting tools, they were realizing that customers were hitting limits, but realizing it too late. And the kind of limit they hit also mattered. They would hit capacity limit, and in which case you need to suggest them to upgrade the storage. They might hit the perf limit, in which case they need to add CPUs or HA pairs. And the bigger problem is that NetApp has a lead sales time. And this means that if the customer hits the limit and they need to requisition a new instance, it'll take time while their workloads cannot run. And that's what we wanted to fix. So what did we do? We were able to take in all of their customer telemetry in addition to text workload information. And we enabled Saji's team to ask natural language questions like which capacity will I hit first? And we were able to give them fine-grained insights like GAA would hit capacity in 78 days or GDX, the performance limit, in 81 days. We were also answering the question of which capacity I'll hit first, using these actionable insights. You should upgrade first, and you should add second. Here are some demos of the kind of performance you can expect with Synthefy APIs. On the x-axis, I have the forecast horizon, and on the y-axis, I have mean absolute percentage error. Since this is an error metric, lower is better. And you can see that Synthefy gives great performance, and the traditional baselines that we ran were so much worse in error, they don't even fit on this graph. So we are able to give you a really good forecast in the 1-month range, and obviously, even though there was a degradation at the 3-month range, we were still able to maintain good performance. We're also able to work and give you the mean days until a particular threshold would be hit. And this was 16 days for storage and 20 days for the critical threshold. Similarly, we're also able to do similar work for the throughput as well. Since customers can run workloads without interruption, NetApp can close sales faster. So closing out, a big thanks to NetApp for the work they've done in bringing us on, and we've had an amazing experience talking to industry experts, talking to other crack builders. These are the chefs behind our secret sauce. Since Synthefy's work is based on original PhD research, it's very difficult to compete with our results. Please do reach out to us either after this event or over mail, and we can talk about how we can solve your problems for you. Thanks so much.